So I wanted to redo my recursion hints video, leaving out all the interminable crap and just get to the point. So when you're doing recursion problems, either you're close or you're not close. And if you don't know what you're doing, you're probably not close. The first thing is read your book or your lecture notes. I know that my daughter, for example, doesn't have a textbook, and other people don't have textbooks. Find one. It doesn't have to, any particular book. Any book that talks about recursion is enough to explain the idea to you. Or just look on the net for an explanation. Then, if you're not able to get the program working, drop back and try to solve a simpler problem, like the factorial problem. That's a really trivial problem to get started with. And you may think it's a waste of time, but it's not, because you're solidifying how this thing works in your mind. Once you do that, start on your real problem, and you want to plan your solution. I mean, get pencil and paper out and plan it before you start typing stuff in. Now, if you think you're close, but you're just not able to figure out why it's not working, then step back and try a recursion depth of like 0, 1, and 2 instead of starting with n equal 12. Start with factorial of 0 and see if that works. Now, in particular, look at the transition behavior of your program between factorial of 0 and factorial of 1 and factorial of 2. You don't have to do all of them, but just do a couple and see what that behavior is, because that'll give you some hints. If you're getting a stack overflow or running out of memory, or the program's not stopping, or just going away for 5 minutes and then giving you an error or something, then that's probably you've got a problem with your termination condition. A really common problem for that is using a single equal sign, which is an assignment operator, instead of the equality comparison operator, which is a double equal sign in your test condition. Now, I guess I thought Java would give you some kind of a warning on that, although I'm not sure. It's worth checking that anyway. Just check your termination condition, your recursion condition, and make sure that they're using a double equal sign there. Now, another problem that can happen is if you're using factorial too big, then but your return type for your variables in your factorial routine are integers. You can get to numbers that are too big to be represented as integers really quickly. So maybe you can make that a long. If it's too big for longs, then try double. But if you use double, you won't be able to keep full precision on everything. And then there are other things that might have to be tried after that if that doesn't work. Let's see. If you're able to get the n equals 0 and n equals 1 to work, but it messes up with n equal 2 or 3, then most of the time it's a variable problem. And not all the time, but like say 90–95% of the time, you have a variable that that's declared with the wrong scope. The quick solution is take all the variables that you're using in the recursive routine and make sure that they're declared locally to that routine, inside, between whatever, I guess the function definition or procedure definition, whatever that is, and make sure that they're defined in there, and make sure that they're static. So if you want to understand what I'm talking about, look on the book, in your book, or on the internet for the terms storage class, static, dynamic. Okay, you want them declared dynamic, and you want the variable, the scope, to be local and not global. So look those things up, and you'll understand what I'm talking about. But just the way to make the things local is just to move them inside the variables that are being used inside that routine. Define them or declare them inside that routine, and then make sure that none of them are declared as static, because that'll mess you up most of the time. Now, sometimes you'll want a static variable in the same way that sometimes you'll want a global variable, or a variable that's at least defined outside of that recursion. But that's not all that common. So those are usually the problems right there. Usually, I mean, it's probably 90–95% of the time. It's one of the things that I've listed right here. So good luck.